All right, so just quickly, this is the solution to yesterday's homework. Um, Now, as you can see, this is a series circuit, okay? This is a series circuit. So just a reminder, in series circuit, the current is the same everywhere, okay? Current is the same everywhere. So in some ways, what we can do is we can start inputting that information here. Okay, so we know I4 is 2 amp. Well, because this is a series circuit and current is everywhere, we can right now just say, well, this is 2 amps. The total current is also 2 amps. Okay, we know that right away. And a couple of things that we can do is this. We're looking for, so we solved this one already. We figured this one already. We need this one here. We also need this one here. We need resistance number 2. Also, we need voltage number 4. Okay. So in this case, now, they didn't, even though this question, they didn't ask for the current for this, for number 2, the resistor number 2. We can still add that in here, okay? Because once we know voltage, once we know current, we can just use Ohm's law to figure out the resistance here. So so just a reminder in terms of, the Ohm's law, V over I, then in this case, resistance equals V divided by I. So R2 equals V2 divided by I2. Okay? Now V2 is 4 volts, I2 it's 2 amp. So in this case, your resistance here should be 2 ohms here. So I'm just going to write that piece of information here. Just like what I said in class, once you found the information and calculate it here, fill it in, it helps you see things, okay? So we figure out what is the resistance number 2. Now, the thing is this, we need to find volt number 4, V4, and we know in the series circuit, now we know that in the series circuit, total voltage equals V1 plus V2 plus V3 plus V4. Okay, so we know that you add up all the voltage together gives you 17 volts. But the problem is that we don't, we right now at the moment, we don't have V3, and certainly we need to find V4. Okay, and we don't have enough information from here to figure out what V4 is. So in this case, what we will need to do is that we go back over here, and we can use Ohm's law again to find out what V3 is. Okay, so we're going to go back to find out what V3 is using Ohm's law. So V3, now we have resistance and we have current. So we're looking for V, so we cover up the V. R is right next to I, so we're multiplying it. So R3 times I3, okay? So R3 is 2 ohms. I3 is 2 ampere. So in this case, voltage for this one, it's just 4 volts. Pretty easy, small number. So we can fill that in here now. V3 equals 4 volts. Now, last but not least, now we have V1, we have V2, we have V3, and we have V total. So we can definitely find V4. So in this case, we're going to go back now. So V total equals V1 plus V2 plus V3 plus V4. So V total is 17 volts. V1 is 3 volts. V2 is 4 volts. V3, we figured it out just now, is 4 volts. So let's add all these up together. 3 plus 4 is 7. 7 plus 4 is 11. So 11 volts plus V4 gives you 17 volts. So 4 volts plus 11 volts gives you 17. So to find what V4 is, it's just 17 minus 11. 17 minus 11. So in this case, it will be 6 volts. V4 is 6 volts. So right now we also have that piece of information here. V4 is 6 volts. Okay? So check your answers. Check your answers. Okay? Now, I'm going to do question number 2. Now, question number 2 is trickier. Now, question number 2 is tricky because right now, at first glance, it's a combination between a series circuit and a parallel circuit. So 2 and 3 here, this is parallel to each other. But if you look at the light bulb 1 and this whole thing, like if we treat this as if its own one thing, as if it is one weird light bulb, this will be in series with each other. Okay? So in this case, so in some ways you have light bulb 1, that is in series with this weird thing here, which make it up of a parallel circuit of light bulb 2 and light bulb 3. Okay? So we can write down here bulb 2 and is parallel to bulb 3. Okay? So bulb 2 is parallel bulb 3. And this whole thing here. And then the bulb 1 here. Bulb 1 is series with, if we treat this whole thing as if its own item, why don't we give it a name? Let's give it a name of, I don't know. Let's give it a name. I don't want to use another letter, because that can be confusing. Let's just say this is its own thing of, let's just say call this alpha. Okay, let's just call it alpha. So it will be series with alpha. Okay, alpha. Alpha is made up of alpha is a parallel circuit of 2 and 3. Okay, so in this case, let's use the rule that we know about parallel circuit, and then we label what we know. Okay, we label what we know. So now in this case here, we know because light bulb 2 and light bulb 3 is parallel. So in this case, light bulb 2 will be equal to the same number. No, this is light bulb 3 equal same number of light bulb 2. Okay, it will be the same number together because they are parallel. Okay, now we know that because this is parallel, current number 2, we don't know what it is, plus current number 3 will give you basically the total of current alpha. Okay, so current alpha, this whole thing here, will be okay. So we have this. So for this smaller circuit, for this smaller thing, so smaller circuit called alpha, in this case here, the total current of this little bit here will be these two current add together. And in terms of voltage, V2 here will be equal to V3 here, simply because they're parallel to each other. Okay. Now, one thing, if we look at all this thing, it can look confusing. But as I said before, let's do the ones that we know. Okay. So we can fill in some of the blanks. So right now here, if you look at light bulb number 1, we have resistance, we have voltage. We can totally find I1. Okay, so I know the question didn't ask for it, but the more information we have of various things, the easier it is for us to find I total. So let's look at that first. I number 1. Now, again, using Ohm's law, we're looking for I, so we cover up I, so V divided by R. So we have voltage 1 divided by resistance 1. Voltage 1 is 5 volts. Resistance 1 is 2 ohms. So in this case here, we have 2.5 ampere. Okay? So here, I1 is 2.5 ampere. Okay? 2.5 ampere. Okay? Now, we know this is I1, it's 2.5 ampere. And as I said before, this here, if we treat this parallel circuit, or this part alpha, if we treat this as a series circuit, because after all, there's only one loop here, if we count this as its own thing, this is in series. So again, in this funny circuit here, the series circuit here, I total is the same thing as I1. So we can say that I total is the same thing as I1 simply because this light bulb 1 is in the same one loop as in the battery. So in this case, I total would also be 2.5 ampere. Okay? I total also equals 2.5 ampere. So we can fill that piece of information here. So 2.5 ampere. Okay. Now we have this piece of information already. We have I1. Now let's go back to this small parallel circuit. Now this is a fun part. This is an interesting part because earlier we said that, hey, you know what? If we treat this as its own thing, this is really just one loop. Okay, so we cover this up and treat it as one load. This is a series circuit because it's just one load. So what it means is that I total would be equals to I1 would be equals to I current of this whole entire thing. Okay. And since what we said earlier, if we treat this whole thing as in one load called alpha, then in this case, this is just like it is alpha. So let's just imagine if I use, I know some of you might kind of find this really confusing. So in this case, let's just treat it as, okay. So rather than looking at individual things, let's just treat it as it is an own one light bulb, right? Combine both together and make a giant light bulb. These are series. So this here would be equal to this part here. And we earlier would call this alpha. So I alpha would be equal to 2.5 amp. Does that make sense? Hopefully you can see that. Okay. Now, but earlier we also said if we combine these two things together, two light bulbs together, that's as if it is a smaller total, alpha 2.5, I2 and I3 add together would equal to I alpha. Because if we only look here, this is a parallel circuit. And in parallel circuit, you add two voltage add together gives you the small total. Okay, so in this case here, I alpha is 2.5 amps, just like what we said earlier. And in this case, I alpha equals I2 plus I3. Okay? I2 plus I3. Now, we don't know what I2 is, but we know I3 is 1 ampere. So in this case, and we know that these two guys add up together will give you 2.5. Okay, so I2 plus 1 amp gives you 2.5 amps. So I2 would just be 2.5 amp minus 1 amp. That will give you 1.5 ampere. Okay, so in this case here, we now know I2 would be equal to 1.5 amps because those two small light bulbs that are in parallel together, when you add the current up going together, that will be 1.5. Okay, so here this will be 1.5 ampere. Okay, so we got that here. Now, what else do we need to find? We need to find. Oh, right. We need to find R3. And in some ways, to find R3, as you know, we have I, but we don't have V3. Okay? So again, let's go back to this whole thing and treat this small parallel circuit as its own one big light bulb. Okay? We treat it like that. And because this is all in series, what we can say is that the voltage for this guy here would really just be the sum. So basically, V1 plus V alpha would equal to 10 volts. Okay, these two add together will give you 10. So let's figure out what this is. V total equals V1 plus V alpha. Okay, the smaller thing. So V total is 10 volts, and V total is 10 volts. Volt 1 is 5, V1 is 5 volts. So we don't know what V alpha is. So in this case, 5 plus V alpha gives you 10 volts. So V alpha would be 10 minus 5 volts, gives you 5 volts. Okay, so it means here, this guy here would be 5 volts. 5 volts. Okay, now again, so this whole thing together equals 5 volts. So which means this is also 5 volts. This is also 5 volts here. I have to speed up. Now, if we look here, we can do another Ohm's law. V3 equals okay. So hopefully this combined together. So V5 divided by 1 will give you 5 ohms right here. Okay. So I hope this makes sense to you. This is considered a tricky type because it's a combination circuit. But we will go over that tomorrow. Okay. Good luck.